put on some music. Hello Earth, welcome to the fourth episode of Making Cell, a series of videos where I create a programming language and environment from scratch called Cell. So this is the fourth episode. If you want to follow along, it might be better that you at least jump to the first one if you haven't done so and review it. We are still bootstrapping absolutely everything from scratch, and yesterday I was trying to figure out what should we do in terms of getting and setting calls. So by the way, I'm putting Alphaville. I will just post the link to the video. It's a great album to have in the background while we think and build this language and environment from scratch. So what I'm thinking is that we want to get calls and process them into Cell. So everything that Cell does within the browser at some point will have to be executed by JavaScript, right? Because that's the actual runtime that we have. So Cell will be constructed from JavaScript in this implementation. So I'm trying to understand the implications of that. What I didn't think through yesterday was the fact that actually, why do we need to take text, receive text, and give out text? And I think there's a very good reason for that, which is the interface of the system is basically going to be connected through a network most of the time, and a network can just basically send linear data, and text is a form of linear data. Is basically a succession of characters that can actually be encoded as binary data. So you cannot really send structured data over the wire that is not representable as a series of zeros and ones. So basically, if we do it as a chain, we can go from, let's say, zeros and ones can become characters. But that can become, actually, the process is a bit more complicated. But there's another step, basically. From zeros and ones, you go to, let's say, groupings of zeros and ones, and then from the groupings of zeros of one, you get a series of characters, and from those characters you get text, and from text you can get structured data. So this is the process, but over the wire it always goes as zeros and ones, which is a sequence, a binary sequence. So this is why here, this is the notes for the previous episode, I'm saying, we need to basically take some text that comes in and process it in Cell, and then generate some text on the way back. So what do we do now? So we know we have, we're going to get some text. In JavaScript, I think if we're interfacing with JavaScript, we don't have to be concerned with the first three elements of this list. We can just basically assume we're getting text. But later when we implement Cell in a more, let's say, not real environment, but let's say if we create a Cell server, we might actually be exposed to the lowest possible level of communication, which is zeros and ones, a sequence of zeros and ones, and therefore we might have to implement all of this. What are we going to do now? We had another problem yesterday, which was what's the internal representation of the data in Cell? What is it going to be? It's a good question. For now, I'm going to go with the assumption that we have always a data space, right? That's pillar 2. We have all the data of Cell in a data space. We can represent that data space as text somewhere. So let's actually figure out where we're going to put these things in JavaScript, because in the end, they're going to be there. They have to be there in JavaScript and on the web browser, right? We have to understand what are the building blocks of the lower level so that you can build Cell atop of that. So for example, we are going to store the data in local storage. Local storage is a place in your browser where you can actually store some data. So we can just look it up here, for example. Local storage allows you to access a storage object for the document's origin. What this means in practice is a place where you can just store text in the browser. And for example, what was the way to use it? Here. So for example, this is a web page, right? So you can do local storage, set, let's say cell, we can call this space cell, and we can just say hello. So we just, no, doesn't exist. Set item, apologies. Why item and not set? God knows. So we're setting item, and then when we're getting it, get item. If we get cell, we get hello. If we get whatever, we get a null. So for now we get cell, right? So we're going to be always, I mean, not always, for now, we're going to be storing stuff in local storage. So, so local storage, we have set item and get item. We have both of these. So, okay, that's where the data could live, let's say. If we, so every single time we make a modification, we do it there, and every time we, let's say, get the actual contents of cell, we just get it. We could also do it in a JavaScript variable, but the JavaScript variable basically is very transient. The moment you close the tab, it's gone. Whereas if you store it in local storage every single time, then it's not gone. It's always there. So, and we're not concerned with efficiency at this point, so we can just directly store it there in local storage for now. In the end, it shouldn't matter that much if it's a variable or not. We're just trying to understand how to bootstrap the system. It's very funny because I've been talking about, not talking about, just thinking about bootstrapping and reading about bootstrapping for ages. But I think this is the very first time I tried to do like really bootstrap a system, and it's quite a workout for the brain. So if anyone's watching this, thanks for being here, because this is probably not so fun to watch. Well, maybe it is. You tell me. So we're going to get and set things from local storage. So the way I see it is like you have your state, or your data actually, or yeah, the data space at a certain point in time, and then a call comes, and then you have a time, and then you have the data space at t+1. So what really makes time, so to speak, is calls happening. Calls that might modify or might not modify the data space. Well, we could actually perhaps say that, and this might be an interesting idea, perhaps every call modifies the data space. Because if it didn't modify the data space, why would you make the call in the first place? You could make an argument that, hey, if I'm reading something from the data space, I am not modifying it, I'm just reading it, right? Read only. But if the data space itself represents the response to your call somewhere, you are modifying the data space. If we go back to what we wrote yesterday, we're going to have a place in the data space called current call. And this current call, we are, sorry, excuse me just for a minute. Yeah, I was just making sure I was recording. So we're going to make sure that we store the latest call that we get and the actual response that we give to it. So if we do that, then it means that even a read modifies the data space. So every call modifies the data space. In the absence of modifications to the data space, there was no call. This is an interesting way of looking at it. And even if we, let's say we didn't store the current call, which I don't think is correct to say, but even if we did that, if the system that makes the call, the read call, right, gets back a response, it does something with that response. It probably stores it in its own self, in its own part of the system. So if your system is also part of the dataspace, you're modifying the dataspace as well. So basically every read is also a write. The only thing that matters is in which way the information flows. But actually, in both cases, both in a read and a write, there's information flowing both ways. There's always a call and always a response. That's actually quite interesting. So there's no such thing of as a one way. It's always two ways. Let's actually see how this would be in practice. So we have these calls that will come from JavaScript. The call will be executed, expanded, and then the data space is going to be changed, and we're just going to save it, right? So I guess at some point we need to start writing some JavaScript to do this. So we could do something like this. We have a call, right? So we have a call, and we actually pass the, well, the function is a call. I guess the function has to be called makeCall because I want the actual call to be the data, and though in so we won't distinguish between data that is just literal data and data that actually represents a sequence. In JavaScript we still have to do that distinction. So we make the call, we pass the call. The call, let's say it's just text. Now the idea would be like you would get the data space like this, get item cell, and if there's if the data space is null, the data space is equals to an empty string, right? Sorry, an empty text. And so in that case where you're getting something that doesn't exist, like this one, like I don't want null. Null is not my friend because it's not one of the 4 data types that we use for data. So there's no need to use null, and we're just going to stay completely away from it. So we're just going to use an empty text instead to represent the absence of everything. And once we do this, we need to send the call somewhere, which is funny because there's nothing yet inside the data space. Like I'm gonna do like send the call to the actual cell, and then we need to get the response, so to speak, and then store the response in the data space, which would be then set to, I know at some point we need to have to have an updated data space here that we store. That I know, there's no way around it. We need to update it, right? So that much is clear. But how? What do we do in the middle? What do I need to do? Well, let's think of it. Perhaps a way to bootstrap something is just to see how you would do it manually, right? So, for example, let's say that manual mode. I am the computer. So let's say I get this call, this example call, which would be get foo, right? Get foo, and then the data space is just empty text. So what I would say is like, hey, first of all, I'm detecting that, hey, this is a call because it starts with add. It's a get call because get comes after the add, and then I'm getting foo. Okay, foo. So I go to the Dataspace, which is an empty text, and I look for foo, and I don't see foo at all. It's nowhere to be found. So what do? I just make the response to be an empty string. Sorry, empty text. Takes me a while to remap my brain. So we go with the example 2. We get this call. And then in the Dataspace is still empty. So now the Dataspace, I'm going to update it to foo bar. I'm just going to set it to that. And then the response will be something that says, okay, it's like, I did it. It's successful. And then the third example would be, I'm getting this. And then the Dataspace starts as foo bar. And then the response would be bar. By the way, okay doesn't need quotes here. You know, it's text. So this is what I would do manually. Now, I need to start dissecting what I do manually. At this stage is like, I look at what I am getting. So we can just start assuming that input only has one line, right? We can assume that for now. Later, very soon we'll have to expand that. So it's like the first thing is what do I do? It's like I split the line by their spaces. I do this in like myself on my eye and my brains. I don't do it in the computer, right? But I just, so for example, we have a get. So this text, if you consider this to be text, the parsed would be, I would just do it like a list, right? Where the first element is at, the second element is get, and the third one is foo, right? So by splitting it with a space, this assumes that none of the words or the elements, actually the values, that's the correct word, have a space in it. I'm just basically doing this. And then I'm doing something like, what's a well-formed call at this stage? Well, there's a few rules. Starts with at, then starts as first element is at. The second element is either get or set, right? Those are the two operations we implement so far. And the third element we could say I need it to be there something, right? Because let's actually think of the corner cases. If we get something like this, we could use that actually as a way to get the entire data space, right? We could just say, I'm not giving you any path, just give me everything. Like in a lot of existing systems, you would do something like get like a wildcard, or give me a slash. But I actually want slash not to be something special. I want to be able to write a system where I can do stuff like this, and this slash has no special meaning. So the absence of a message, just the presence of a destination, but no, the absence of a message could be meaningful. That's an interesting thing. That's an interesting thing. So let's actually not even require a third element in the case of get. If second element is get, there's no other requirements, because you could pass nothing, or you could pass what? You could pass a number, and if the whole thing happens to be a list in the entire data space, you're organizing it as a list instead of a hash, which I don't think you would ever do, but if you wanted to do it, you could do it like that. And if it was, if you pass text, you're fine. And if you pass a lot of this, it should also be fine. You might not find anything, but this is a well-formed call, so there's no other requirements for the get. And if there's the second element is set, then we need to set something to something else, right? We could, but then again, you might want to overwrite the entire data space. By the way, all of these possibilities and the corner cases, I am really cribbing or copying one of the best things that Redis, the database or the data structure server in memory, if you don't want to call it the database, has, which is basically allowing for these corner cases. Like, for example, when you add an element to a list using an operation for that, which would be lpush, for example, if I remember correctly, or rpush. If the list doesn't exist, Redis creates it for you on the same operation, so you don't have to create the empty list first and then push something to it. And that's really powerful, that type of thinking. So I'm gonna use some of that as well. So for example, in this case, if I want to overwrite the entire thing, the same way that it's comfortable to be able to get the entire thing, particularly when you're bootstrapping, right? Then it's comfortable to actually be able to overwrite the entire thing. Why not? If you cannot do that, it's because of a permissions thing, which we will have to add later, not now. So if the second element is set, we don't require a destination necessarily. Destination in the sense of where you're going to store what you're passing, but you do need something to place, right? You need actual contents. But then again, let's say that you pass nothing. What that could do effectively is just reset the entire data space to an empty text. It's not bad, actually. So there's no other requirements really for set either. I mean, you could say that's really open-minded, but I actually think it's the correct decision here, completely. So let's say you could do, this gives you the entire, this sets the entire data space to nothing, basically. And then if you do something like set foo, would this be well formed? You could say that this is basically setting foo to an empty text. But I don't like this. I would rather you tell me this. Like, I think that either you send me nothing or you send me two things after set. But I don't want you to send me only one. But then again, if you send me, like, how am I going to be able to rewrite the entire data space if you only send me one thing? I can't. If I want to let you do that and rewrite the entire data space with one call, I have to let you send one. So for example, if you would set foo, we would set the entire data space to foo. And interesting enough, set foo bar sets entire data space to foo bar. So in this case, the data space would be text, and in this one, it would be a hash. Interesting. I'm trying to figure out if I'm missing something, or it can be as simple as this, really. Because then it's really open. All I care about for well from call is that the first element is an add, and the second one is a get or a set. Okay, so let's just go with the base case. Let's say basic manual implementation, let's say. Of course, it cannot be manual. We're just doing it by hand to understand what it should be, and then we are going to code it somehow in JavaScript, I guess, at the beginning, and then later we'll see how much it takes us to be able to bootstrap the system. So it would be like this. If you have add get, no third element in the call, respond with the entire data space. Cool. If we have add get and there are more elements, find them, find them. So let's implement this, right? I'm oscillating between for data and a more like informal notation all the time. Yeah, we'll see if that inconsistency comes back to bite me, but for now we're still doing design notes. We'll see. Depending on my mood, sometimes I completely define things in terms of for data, even with the notes that I make, and sometimes I don't. The code definitely and the data have to be in for data. That's a rule, because remember pillar one, pillar one always. So if we are add get and there are more elements, well, not more elements, no third elements in the call, I guess. Find them. And if we go back to the equation here, let's remember this rule, which is this is the structure of a call: destination, message, response. So if we are getting a call and we're splitting the call, which is a single line, by spaces, the first element is always going to be an add, the second one is going to be a destination, and the third and fourth and fifth and whatever, how many elements you have there, is the message. Okay, so if there's add get and there are more elements in the call, we need to find them. Now, how do we find them? Well, let's say we have to find foo, right? So we would go to find foo. We're always starting from the top level of the data space, which is the left side. So for example, find them would be this would be the algorithm. I'm gonna nest it. So it would be like go line by line on the data space. So we're already processing the data space as text, right? Which is going by line by line. If the line starts with the message, which is all the third, fourth, etc. Elements of the call, joined by a space. This, don't forget this, and we will have to probably do some modification. Let's say you send two spaces instead of one. We're going to just treat that as one space. Basically, it's called trimming, if I remember correctly. We'll get to that later, but we have to do it indeed. Those type of details are what make, in my experience, quality systems, right? Systems that have really good quality. So the third four elements of the call are joined by a space. If the line starts with that message, this actually is as simple as this: remove the message take that line, remove the message from it plus one space and make that the response. Yeah, this actually works. I think it's a consequence of for data being the way it is. So let's say we're assuming a lot here. We'll have to make it better later. So for example, we have let's say foo bar alphabeal 1969. I'm just putting whatever bullshit here. So this is Dataspace. So if you do add get, first line, no much. Actually, let's put this as a. Yeah, but this is gonna be considered as. Let's just consider it as text, which also is bringing up another little small can of worms, which is am I going to be supporting multi-line text or not? Oh man, it's bootstrapping. You're surrounded by problems. I love it. It's really cool. I know. I really mean it. That is cool. I'm not being. I'm not saying one thing and thinking something else. I really mean it. It's cool. I'm having a lot of fun actually. So you just. But let's not get there yet. We have 2 lines here. Yeah, we need multi-line text, but it kind of screws up everything in for data, because in for data we have this notion that every line has an end value. But what's the alternative? To have stuff like this is fucking unusable. I've been using systems with /n. We have to support multi-line text. There's no way around it. We will support multi-line text. Yeah. When I got this from the Worse is Better paper, which I highly recommend to give a look at, and I heard something that makes sense even if you're a vegetarian or a vegan, which is it takes a tough cook to make a tender chicken. So this type of decision will probably just benefit our users and it just make the implementation more difficult. But in this case, I think it's worth it, because I would gladly pay that price so that I don't have to use \n within a certain text to actually put the new lines. Okay, let's see the consequences of our bold decisions now in action. So the first line, there's no much, because it's what? It's alphaville 1969. Second line, match. So we take foo bar, remove foo and the space, and get bar. We put bar in the response, which would be current call and then equal. That works. And we're also assuming that there's no other entry for foo, but that's the case because it's not a valid data space if you have something like this, especially if it's separated, right? This is not right. The way you would write this actually would be like this. So that's where we're starting to get to multi-line outputs, which basically is the way that you would respond with a list or an object. Okay. I think we're getting somewhere here. We might be even able to tackle the problem of multi-line here. Maybe we should just give it a shot. Why not? Okay. So